We're trying to give your agents the autonomy and the performance that they need to be successful at scale without introducing the risk of letting them just kind of run rampant through your ecosystem.
Hello and welcome to this week's FastChat on Guardrails for AI agents. Last week, we talked about runtime governance and why it's critical for securing agentic AI. Governance defines intent, goals, and accountability, but governance alone doesn't stop risk. This week, we're going one layer deeper. We're talking guardrails with Rampart-AI's CTO, Jacob Staples.
Hey, Daphne. Great to be here and looking forward to talking with you today.
To begin, a simple way to think about governance versus guardrails is this. Governance is the rules of the road. Guardrails are the barriers, sensors, and controls that keep the vehicle from leaving the road. You can publish speed limits all day, but without guardrails, cameras, and enforcement, accidents still happen. And AI is no different. So Jacob, to level set, how do you define guardrails for AI agents?
All right, so I should probably start by pointing out that we're talking here about guardrails with a lowercase g as a concept, as opposed to Amazon's guardrails with a capital G for Bedrock, which is a product. And, as for what that lowercase g guardrails actually do, like in a nutshell, they're kind of a family of protections that are going to keep your agentic system safe as it goes about its business. That's going to involve interactions with large language models, which are kind of like the brains of an agentic system. They're going to involve using tools to achieve the objective of the agentic system. And tools are kind of how the agent interacts with other systems, for example, via an API. This involves interacting with data, whether that comes directly from a user, whether it comes from an internet and a public endpoint, or it's loaded from a local RAG store or some other source, and interactions with other agents as well, each of which are going to have their possibly competing objectives and permission sets, et cetera. So to kind of get us started, let me quickly give you a few examples of guardrails. Right? Probably the most obvious example are going to be the content safety mechanisms that block or filter, unsafe or harmful or disallowed content. Stuff like hate speech or incitement to violence, self-harm, those kind of verboten subjects that, the OpenAI type providers in the world are blocking today. Another example would be kind of like the human in the loop guardrail type systems, and these are things that require human review or approval for what would typically be perceived as high-risk actions or outputs. So when your Claude Code instance on your laptop asks you for permission to write to a file system where you've checked out some code, this is kind of an example of that. And those are kind of like the bare minimum of what guardrails encompasses. There's a whole slew of them. A couple of other examples would be things like data protection guardrails to save you from a data exfiltration type of an attack. There's also prompt injection guardrails to protect you from bad content or instructions that are injected into inputs to your system. Tool use guardrails, access and authorization guardrails. And then you have more exotic and more rubber on the road type of guardrail systems like rate limiting, output validation, and that kind of thing. So there's a lot out there.
What is the relationship between guardrails and runtime governance?
So governance is one of those really messy, kind of buzzy terms that has this, I call it a fuzziness around it, because it's been used by a lot of different people in a lot of different ways in a very short amount of time. And it kind of has some baggage around its neck as a result of that. My view of governance, and the one that we take at Rampart-AI, is that it involves the kind of foundational concepts that form the frameworks and the policies and the processes and the controls that are being used by an organization to ensure that the artificial intelligence systems and software that are being developed are not just developed, but deployed and operated responsibly. So there's this deployed, developed, and operated responsibly triad that I consider to be the kind of foundation of this governance word. And that means that governance addresses things like how decisions in your organization about AI are made and how they're enforced. And that includes kind of the more boring things, but important things like risk management and accountability and transparency. And then you have ethical considerations, legal and regulatory concerns are increasingly popping up. And then, of course, security, which is the angle that we're kind of attacking this problem from. So in practice, governance is going to define within your organization who can build and who can deploy AI and how they go about doing that. And really, it's increasingly starting to address things like how risks inherent in AI, like bias or misuse or model failure, can be assessed and can be mitigated, and how those systems are going to be monitored and audited over time. So that's kind of governance in a corporate nutshell. And once you understand governance, it's easy to see how guardrails fit in. They're really just a tool, one of many, for enforcing different aspects within your organization of that governance process. So if you're in the business of doing interesting work, you probably have a policy within your organization that says something like, we like to keep our secret sauce secret, and therefore our AI systems should not emit proprietary data to the public internet. And that would be things like source code or emails. You want to protect those and keep those kind of close to the vest. And there are guardrails that do exactly that, right? They look for evidence of proprietary data leaking out of your system, and then they can step in and block that sort of thing from happening.
It seems like everyone is making guardrails. So what's the differentiator?
So I'd say that right now we're in this kind of, as you're hinting at, what I would call a guardrails bonanza, right? We find ourselves here, and it's a really good indicator that the underlying problem space isn't terribly well defined yet, and that it's not just undefined, but it's changing rapidly. So in this kind of environment, there's this sort of, I call it an annealing process. You kind of think of it as an evolutionary process, depending on how you look at things. But there's a whole bunch of products out there that have emerged to address this problem of the month, which is securing these agentic systems via guardrails. And there's going to be, and there already is, kind of a funneling process, a winnowing process in progress. And that's going to pick out a couple of the leading technologies, a couple of the winners, if you will. And that will result in a smaller down select of viable approaches going forward. And then, next month, a new problem is going to emerge, like a regulation, for example, that wasn't there the month before. And that's going to make us kind of rethink things and then see results in a different or from a different perspective. And that, of course, results in another round of mutations or innovations and then further down selections. And just to be clear, like right now, we are in kind of the very early stages of this. So there's a lot of things that are up in the air. I'd say that there are probably three things to keep straight in the differentiation mindset. So first off, there's kind of what the guardrail is trying to do, sort of the objective of the guardrail. Why did you introduce this thing into your system? And that's what I talked about earlier, is the difference between something like a content safety guardrail and a prompt injection detection guardrail or a tool use guardrail. And there's a wide spectrum, like I hinted at earlier, of protection domains at play here. Then there's kind of how the guardrail fits into your system architecturally. So that's another differentiator. And that can range from rudimentary protections that are being baked into the model from inception. And this is increasingly a formalized thing from some of the foundation model providers. It can also include approaches that are platform provided, but not necessarily baked into the LLM during training. And these are kind of like the things that are provided by the foundation model, but sit inherently outside of the LLM itself. And then you have the middleware type of solutions that act as a gateway of sorts. And these are kind of providing a WAF-like capability to filter out problematic interactions. You can go all the way down to application layer here, right? So we're just going down the stack. And we're talking about application layer. We're looking at things that are supported by libraries and instrumentation. That may involve code changes or may not involve code changes, but the application layer can do different things than like a foundation model type implementation. And what I would say is that even though there's a lot more heterogeneity in how the architectural space is being explored here, I would say that it's easier to enumerate than the protection space. Like, we understand architectures pretty well since we've built a lot of cloud-based systems to date. Finally, there's the engineering angle of how the guardrail actually works. So does it use a machine learning style classifier operating on tokens, kind of like the spam filters of the past? Or does it use something that's more powerful, like a large language model that's been trained specifically on adversarial examples and how to identify them? Something like what LlamaGuard does today. And it turns out there's been some interesting research done recently that hints at that second approach being almost a requirement in the real world. You need a decently powerful model looking at these interactions to make sense of it, or you're going to enter into this inevitable cat and mouse game and eventually wind up missing things.
Moving forward, what technology approach will be required to make effective guardrails?
My honest take on this is that there's not going to be there's not an answer to this question yet, and there's not a one size fits all approach implementation wise. It's not clear yet what the winning strategy is going to be. So some classes of guardrail can certainly be implemented quickly and easily using those lightweight traditional machine learning type classifier systems that I talked about earlier. But generalizing the concept of guardrails, that's in my mind, it's going to be tough. And that's where the no correct choice comes into play here. What I will say, and I admittedly am speculating a bit, but is that in that context, it's going to turn out to be, it's going to be infinitely more valuable in building guardrails to have kind of like a zero trust approach that's powered by context. So a zero context guardrail is inherently going to be more constrained than one that understands the sequence of events that leads up to a specific thing that it's seeing now. Whereas a system that understands how we got here, how we got to this place, how we got to this action, is going to have a lot more at its disposal to make sense of whether that's a reasonable thing to do or see or be interacting with. And I would say that maybe a more important thing than trying to pick winners today is arguably going to be focusing on building out a strategy for testing these things. And that's a problem that we and my team are intimately cognizant of, and it's something that we're building out tools to support right now. It's important to be able to poke and prod your agentic systems and see how well, or more realistically, how poorly they're going to respond to different types of malicious interactions. And our position is that having that automated evaluation strategy is really the only feasible way to evaluate a realistically complex agentic system, as it's deployed in the wild, because there's so many things changing so rapidly that, again, focusing on getting the winning strategy up front is you're just going to wind up going down the wrong path if you do that. The models change too rapidly, the attack landscape changes too rapidly, and human operator time is expensive, right? So what we need is automation and automated testing strategies to explore this stuff.
As agents become more adaptive and unpredictable, what role do guardrails play in keeping them inside their quote safe zone? And how does Rampart approach this?
Something that we've been saying for years now is that the right way to handle the security of an empowered, autonomous, or in this case, agentic software system is with a kind of zero trusty approach that is itself powered to some extent by AI. So it's going to be something that builds a model of your agent's typical interactions with the host platform and with other agents and with different tools, et cetera, over time. And then instead of focusing on known anti-patterns or pathologies or attack signatures, what it's going to do is it's going to look for deltas and differences in behavior between what it's seen before and what's happening in real time. And it's going to zero in on those and use the ability of things like large language models to handle subtleties that are entirely going to be lost in rule-based systems and heuristics. And that kind of gives you the best of both worlds. You can have your cake and eat it too. You can catch novel exploits while not getting lost in a sea of false positives. And if you're still listening, then I'm probably preaching to the choir here. But essentially, what we're doing with Rampart, we're trying to give your agents the autonomy and the performance that they need to be successful at scale without introducing the risk of letting them just kind of run rampant through your ecosystem. So we're trying to keep things from going fully into what I would call Lord of the Flies territory, where you drop your agents into the jungle and then suddenly they're waging war either against each other or against your system or against other rules that you've got in place to protect yourself.
Jacob, thanks for sharing your expertise on guardrails for AI agents.
Thank you, Daphne. It's been a great chat.
To learn more about how Rampart-AI helps secure agentic AI in real time, visit rampart-ai.com and navigate to the Rampart Armor page. Until next time, stay secure.